So let's take a look at the net change theorem. So the formula for the net change theorem is f of b equals f of a plus the integral from a to b of f prime of x dx. So sometimes you'll be given a defined value like f of a, and you'll be given the derivative equation. And the problem might ask you to find a new value, f of b. So in order to find the new value, all you have to do is take the initial value and add it to the integral of your rate of change, which is your derivative equation. So for number 1, we have if f prime of x equals 2x squared minus 2 and f of 0 equals 5, find f of 2. So once again, the net change theorem formula is f of b equals f of a plus the integral from a to b of f prime of x. Since f of b is the value we're trying to find, or that new value we're trying to find, in the problem is asking us to find f of 2. So that will be our f of b that we're trying to find. F of a is our given initial value, and our given initial value is f of 0 equals 5. And then obviously our derivative f prime of x is 2x squared minus 2. And then our a and b bounds, from which we are integrating, are just our x values. So we're going from 0 to 2. So if I were to set up the formula, we have f of b, which is f of 2. So f of 2, because that's the value we're trying to find. So f of 2 equals f of a, and remember our f of a is f of 0. That's their given value. So f of 0 plus the integral. And once again, our a and b bounds, so we're going from the x value of 0 to the x value of 2. So from 0 to 2 of f prime of x, which is obviously 2x squared minus 2. So if I were to simplify this a little bit further, I can still put f of 2, and we know f of 0 is equal to 5. So I will replace f of 0 with 5. So we get 5 plus, once again, the integral from 0 to 2 of 2x squared minus 2. And now I'm just going to focus on the integral and integrate this function. So if I were to integrate 2x squared minus 2, we just use the power rule. So 2x cubed over 3, and the integral of 2 is 2x. And once again, we're going from 0 to 2. So when I plug in my top bound 2 into the equation, I'll get 2 cubed, which is 8, times 2, 16. So we get 16 over 3 minus 2 times 2, which is 4. And then minus, when I plug in the bottom bound 0, I'll just get 0 on 0 minus 0. So I can change 4 to have the common denominator, so we get 12 over 3. So 16 over 3 minus 12 over 3 minus 0. And so we'll get 4 over 3 as the integral of 2x squared minus 2 from 0 to 2. So once again, f of 2 is equal to 5 plus the integral from 0 to 2 of 2x squared minus 2. And we found the integral to be equal to 4/3. So f of 2 is going to be equal to 5 plus 4/3. So then f of 2, if we put common denominators, we get 15 over 3 plus 4 over 3. And that's going to be equal to 19 over 3. So that is the value of f of 2. So now on to number 2, if f prime of x equals 4 sine squared of 2x and f of 2 is negative 2, set up a formula to find f of 3. So once again, I'm going to write out the formula. So f of b equals f of a plus the integral from a to b of f prime of x dx. So since f of 3 is our unknown value that we're trying to define, that is going to be equal to our f of b. So we're going to write f of 3 on the left side of the equal sign. Then f of a is our defined value. We are already given that f of 2 is equal to negative 2. So f of 3 is going to be equal to f of 2 plus the integral from a to b, and our x values we're going to are from 2 to 3. So we're going from 2 to 3 of f prime of x, and f prime of x is obviously 4 sine squared of 2x. And if I were to just simplify a little bit further, I can define f of 2. So I'll write it out as f of 3 is equal to f of 2, which is f of 2 is equal to negative 2. So we have f of 3 equals negative 2 plus the integral from 2 to 3 of 4 sine squared 2x dx. And obviously just asked to set up a formula. So this will be the formula to find what f of 3 equals to.